NEC 400 prohibits using a cord as a substitute for fixed wiring. UL 1363, the standard for relocatable power taps, also follows this principle by requiring these devices to be non-permanent. When an equipment bench is purchased with a powered outlets option featuring a raceway, receptacles, circuit breaker, and pilot light screwed into the countertop with a cord and plug connection, its classification becomes a key consideration. The UL listing in accordance with 1012, which covers power units other than Class 2, adds another layer of complexity. UL 1012 Section 1.2 outlines requirements for general-purpose power supplies and power supplies used in household appliances, school laboratories, cathodic protection equipment, power supply battery charger combinations, and industrial equipment, dividing them into two classes. One class is for those rated 10 kV or less, and the other is for those rated more than 10 kV. The question then arises, is such a bench with outlets and a cord considered a piece of industrial equipment subject to frequent interchange or a substitute for fixed wiring? NEC 400 and UL 1363 clearly state that using a cord as a substitute for fixed wiring is not allowed. This is to ensure permanent and safe electrical connections are maintained. The UL listing for power units other than Class 2 suggests that the equipment bench is classified as industrial equipment rather than simply a bench with outlets. The likely reason for this classification is the bench's intended use and design, which allows it to be easily relocated, similar to battery chargers and other industrial equipment. Therefore, the bench with outlets and cord is not considered a substitute for fixed wiring based on NEC 400 and UL 1363 standards. Instead, it is classified as industrial equipment, allowing its use in accordance with the manufacturer's instructions and applicable industrial safety regulations. In electrical installations, the National Electrical Code, or NEC, serves as a cornerstone for safe practices. Specifically, NEC Section 400 addresses the requirements for flexible cords and cables, emphasizing their proper use and limitations. A critical aspect of this section is the prohibition of using flexible cords as a substitute for the fixed wiring of a structure. Fixed wiring refers to the permanent electrical infrastructure installed within walls, floors, and ceilings, designed to provide a continuous and reliable power supply. Flexible cords, on the other hand, are intended for temporary connections and portable equipment. The NEC recognizes that substituting flexible cords for fixed wiring can lead to several hazards. Firstly, flexible cords are not designed to withstand the same level of physical stress and environmental conditions as fixed wiring. They are more susceptible to damage from abrasion, moisture, and excessive bending, which can compromise their insulation and lead to short circuits, ground faults, and electrical fires. Secondly, flexible cords typically have lower ampacity ratings than fixed wiring. Overloading a flexible cord by connecting it to a circuit with a higher current demand than it is designed to handle can cause overheating and insulation breakdown, increasing the risk of fire. Thirdly, the improper use of flexible cords can create tripping hazards and obstruct pathways, posing safety risks to occupants. To prevent these hazards, the NEC outlines specific requirements for the use of flexible cords. These include ensuring that cords are used only for their intended purpose, that they are protected from physical damage, and that they are not concealed within walls, floors, or ceilings. Additionally, the NEC mandates that flexible cords be properly terminated with suitable connectors and strain relief devices to prevent stress on the connections. Understanding and adhering to the NEC requirements for flexible cords is crucial for maintaining electrical safety and preventing potential hazards. By recognizing the limitations of flexible cords and using them appropriately, electricians and other qualified professionals can ensure that electrical installations are both safe and compliant with industry standards. UL 1363, the standard for relocatable power taps, plays a vital role in ensuring the safety and performance of power strips and surge protectors. These devices, commonly used in homes, offices, and workshops, provide multiple electrical outlets from a single wall outlet, allowing users to power several electronic devices simultaneously. UL 1363 outlines specific requirements for the design, construction, and testing of relocatable power taps to minimize the risk of electrical hazards. These requirements cover various aspects of the product, including its enclosure, internal wiring, overcurrent protection, and grounding. One of the key requirements of UL 1363 is that relocatable power taps must be non-permanent. This means that they are intended for temporary use and should not be used as a substitute for permanent wiring. The standard recognizes that using power strips as a long-term solution can lead to overloading of circuits and potential fire hazard. To address this concern, UL 1363 mandates that power strips be equipped with overcurrent protection devices, such as circuit breakers or fuses. These devices are designed to interrupt the flow of electricity in the event of an overload, preventing overheating and potential fires. Additionally, UL 1363 requires that power strips be constructed with durable materials and have adequate strain relief to protect the internal wiring from damage. The standard also specifies requirements for grounding to ensure that users are protected from electric shock. Compliance with UL 1363 is essential for manufacturers of relocatable power taps. Products that meet the standard's requirements are marked with the UL listing mark, which indicates that they have been tested and certified to meet safety and performance standards. Consumers can look for the UL listing mark when purchasing power strips to ensure that they are buying a safe and reliable product. By adhering to UL 1363, manufacturers can help prevent electrical hazards and provide consumers with peace of mind. The standard's comprehensive requirements ensure that relocatable power taps are designed and constructed to withstand the rigors of everyday use and provide a safe and convenient way to power multiple electronic devices. UL 1012 is a comprehensive safety standard that focuses on power supplies and power units, ensuring they meet stringent safety requirements to protect users from potential hazards. This standard covers a wide range of power supplies, including those used in household appliances, school laboratories, industrial equipment, and various other applications. UL 1012 divides power supplies into two main classes based on their power ratings. The first class includes power supplies rated 10 kV or less, while the second class covers those rated more than 10 kV. This classification helps to differentiate the safety requirements based on the potential risks associated with different power levels. The standard addresses various safety aspects, including electrical shock hazards, fire hazards, and mechanical hazards. It sets requirements for the design, construction, and testing of power supplies to minimize these risks. Some key areas covered by UL 1012 include insulation, grounding, overcurrent protection, and temperature limits. Insulation requirements ensure that live parts are adequately insulated to prevent electrical shock. Grounding requirements provide a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Overcurrent protection devices, such as fuses or circuit breakers, are required to protect the power supply and connected equipment from damage due to overloads or short circuits. Temperature limits are set to prevent overheating, which can lead to insulation breakdown and fire hazards. To comply with UL 1012, manufacturers must submit their power supplies to a UL-approved testing laboratory for evaluation. The laboratory will conduct a series of tests to verify that the power supply meets all of the standard's requirements. If the power supply passes the tests, it will be listed by UL and marked with the UL listing mark. This mark indicates that the power supply has been independently tested and certified to meet safety standards. Consumers can look for the UL listing mark when purchasing power supplies to ensure that they are buying a safe and reliable product. Compliance with UL 1012 is essential for manufacturers of power supplies. By adhering to the standard's requirements, manufacturers can help prevent electrical hazards and provide consumers with peace of mind. The standard's comprehensive requirements ensure that power supplies are designed and constructed to withstand the rigors of everyday use and provide a safe and reliable source of power. When examining the classification of an equipment bench equipped with powered outlets, several factors must be considered to determine whether it should be classified as industrial equipment or simply as a substitute for fixed wiring. These factors include the design, intended use, and applicable safety standards. Firstly, the design of the equipment bench plays a crucial role in its classification. If the bench is specifically designed for industrial applications and incorporates features such as heavy-duty construction, robust wiring, and specialized components, it is more likely to be classified as industrial equipment. On the other hand, if the bench is simply a standard workbench with a power strip attached, it may be considered a substitute for fixed wiring. Secondly, the intended use of the equipment bench is an important consideration. If the bench is intended for use in an industrial setting where it will be subjected to frequent movement, heavy loads, and harsh environmental conditions, it should be classified as industrial equipment. In contrast, if the bench is intended for use in a residential or office environment where it will remain in a fixed location and be subjected to less demanding conditions, it may be considered a substitute for fixed wiring. Thirdly, applicable safety standards such as NEC 400, UL 1363, and UL 1012 provide guidance on the classification of equipment benches. These standards outline specific requirements for electrical wiring, overcurrent protection, and grounding, which can help to determine whether the bench meets the criteria for industrial equipment or fixed wiring. In general, an equipment bench with powered outlets that is designed for industrial use, intended for frequent movement and heavy loads, and complies with applicable safety standards is likely to be classified as industrial equipment. On the other hand, a standard workbench with a power strip attached that is intended for residential or office use and does not meet the requirements for industrial equipment may be considered a substitute for fixed wiring. It is important to consult with a qualified electrical inspector or engineer to determine the appropriate classification for a specific equipment bench based on its design, intended use, and applicable safety standards. This will ensure that the bench is installed and used in a safe and compliant manner. Understanding the difference between industrial equipment and fixed wiring is crucial for ensuring electrical safety and compliance with applicable codes and standards. Industrial equipment is typically designed for heavy-duty use in industrial settings, while fixed wiring refers to the permanent electrical infrastructure installed within buildings. Industrial equipment is often portable or relocatable, allowing it to be moved around as needed. It is typically connected to the electrical system via flexible cords and plugs, which provide a convenient way to connect and disconnect the equipment. Fixed wiring, on the other hand, is permanently installed within the walls, floors, and ceilings of a building. It consists of conductors, conduits, and boxes that are designed to provide a continuous and reliable power supply to various electrical devices and appliances. One of the key differences between industrial equipment and fixed wiring is their intended use. Industrial equipment is typically used for specific tasks or processes, while fixed wiring provides a general-purpose electrical supply for the entire building. Another difference is their durability and resistance to environmental conditions. Industrial equipment is often designed to withstand harsh conditions such as dust, moisture, and vibration, while fixed wiring is typically protected from these elements by the building's structure. It is important to note that using flexible cords as a substitute for fixed wiring is generally prohibited by electrical codes. Flexible cords are not designed to withstand the same level of physical stress and environmental conditions as fixed wiring, and they can pose a safety hazard if used improperly. Therefore, it is essential to ensure that all electrical wiring is installed in accordance with applicable codes and standards, and that flexible cords are used only for their intended purpose. In some cases, it may be necessary to use industrial equipment with a cord and plug connection in a location where fixed wiring is not readily available. In these situations, it is important to ensure that the equipment is properly grounded and that the cord is protected from damage. Additionally, it may be necessary to install a dedicated circuit for the equipment to prevent overloading the existing electrical system. Overall, understanding the difference between industrial equipment and fixed wiring is essential for ensuring electrical safety and compliance with applicable codes and standards. By using the correct type of wiring for each application, you can help prevent electrical hazards and ensure a safe and reliable electrical system. The National Electrical Code, or NEC, plays a crucial role in establishing safe electrical practices and standards for various types of equipment and wiring. Several NEC articles are particularly relevant when considering the classification of an equipment bench with powered outlets. NEC Article 400, as previously mentioned, addresses the use of flexible cords and cables. It prohibits using flexible cords as a substitute for fixed wiring, emphasizing the importance of permanent and safe electrical connections. This article is relevant because the equipment bench in question has a cord and plug connection, which raises the concern of whether it is being used as a substitute for fixed wiring. NEC Article 300 covers general wiring methods and materials. It provides requirements for the installation of wiring in various environments, including industrial and commercial settings. This article is relevant because the equipment bench may be used in such settings, and its wiring must comply with the applicable requirements. NEC Article 430 addresses motors, motor circuits, and controllers. If the equipment bench includes any motor-operated devices, such as fans or pumps, this article will be relevant. It provides requirements for motor protection, control, and wiring. NEC Article 440 covers air conditioning and refrigerating equipment. If the equipment bench includes any air conditioning or refrigerating equipment, this article will be relevant. It provides requirements for the installation and wiring of such equipment. NEC Article 500 through 516 address hazardous locations. If the equipment bench is located in a hazardous location, such as a factory with flammable materials, these articles will be relevant. They provide requirements for the installation of electrical equipment in hazardous locations to prevent explosions and fires. In addition to these specific articles, other NEC articles may be relevant depending on the specific design and use of the equipment bench. It is important to consult with a qualified electrical inspector or engineer to determine the applicable NEC requirements for a specific installation. By adhering to the NEC, you can ensure that electrical equipment is installed and used in a safe and compliant manner, minimizing the risk of electrical hazards. When evaluating the classification of an equipment bench with powered outlets, the UL listing plays a significant role in determining whether it is considered industrial equipment or a substitute for fixed wiring. UL, or Underwriters Laboratories, is an independent organization that tests and certifies products for safety. A UL listing indicates that a product has been tested and meets certain safety standards. The specific UL standard to which the equipment bench is listed is a key factor in its classification. In this case, the equipment bench is UL listed in accordance with 1012, which covers power units other than Class 2. This listing suggests that the equipment bench is considered a power unit, which is typically classified as industrial equipment. However, it is important to understand the scope of UL 1012 and how it applies to the equipment bench. UL 1012 covers general-purpose power supplies and power supplies for uses such as to supply some household appliances, school laboratories, cathodic protection equipment, power supply battery charger combinations, and industrial equipment. The standard divides power supplies into two classes based on their power ratings, those rated 10 kV or less and those rated more than 10 kV. Given this information, it appears that the equipment bench falls under the category of industrial equipment. The UL listing indicates that it has been tested and meets the safety requirements for power units used in industrial applications. However, it is important to note that a UL listing alone does not automatically classify a product as industrial equipment. Other factors, such as the design, intended use, and applicable NEC requirements, must also be considered. In general, an equipment bench with powered outlets that is UL listed as a power unit, designed for industrial use, and intended for frequent movement and heavy loads is likely to be classified as industrial equipment. On the other hand, a standard workbench with a power strip attached that is not UL listed as a power unit, intended for residential or office use, and does not meet the requirements for industrial equipment may be considered a substitute for fixed wiring. It is important to consult with a qualified electrical inspector or engineer to determine the appropriate classification for a specific equipment bench based on its UL listing, design, intended use, and applicable NEC requirements. This will ensure that the bench is installed and used in a safe and compliant manner. Industrial safety regulations play a vital role in ensuring the safety of workers and the proper use of equipment in industrial settings. These regulations often address the use of electrical equipment, including equipment benches with powered outlets. The specific industrial safety regulations that apply to an equipment bench will depend on the location and type of industry in which it is used. However, some common regulations include those related to electrical safety, lockout/tagout procedures, and personal protective equipment. Electrical safety regulations aim to prevent electrical hazards such as electric shock, arc flash, and fires. These regulations typically require that electrical equipment be properly grounded, that wiring be installed in accordance with applicable codes, and that workers be trained in safe electrical work practices. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair. These procedures require that equipment be de-energized and locked out before any work is performed, and that a tag be attached to the equipment indicating that it is out of service. Personal protective equipment, or PPE, is equipment worn by workers to protect them from hazards. Common types of PPE include safety glasses, gloves, and footwear. The specific PPE required for a particular task will depend on the hazards involved. In addition to these general regulations, there may be specific regulations that apply to equipment benches with powered outlets. For example, some regulations may require that the benches be equipped with ground fault circuit interrupters, or GFCIs, to protect workers from electric shock. Other regulations may require that the benches be inspected regularly to ensure that they are in good working condition. It is important for employers to be familiar with the applicable industrial safety regulations and to ensure that their workers are trained in safe work practices. By following these regulations, employers can help to prevent accidents and injuries and create a safe working environment. In the context of an equipment bench with powered outlets, several factors determine whether it's classified as industrial equipment or a substitute for fixed wiring, impacting its usage and compliance with electrical and safety standards. Firstly, consider the design and construction. Industrial equipment typically features robust construction, heavy-duty wiring, and specialized components suited for demanding industrial environments. If the bench is built with these characteristics, it leans towards being classified as industrial equipment. A standard workbench with an attached power strip, lacking these features, might be seen as a substitute for fixed wiring. Secondly, look at the intended use. If the bench is designed for industrial settings, where it's frequently moved, handles heavy loads, and withstands harsh conditions, it's more likely industrial equipment. A bench intended for a fixed location in a residential or office environment is more likely a substitute for fixed wiring. Thirdly, consider the UL listing and applicable standards. Compliance with UL standards, particularly UL 1012 for power units, suggests the bench is industrial equipment. However, the UL listing alone isn't definitive. It must be considered alongside the design, intended use, and NEC requirements. Fourthly, observe the portability and relocation. Industrial equipment is often designed for easy relocation using flexible cords and plugs for convenient connection and disconnection. Fixed wiring, in contrast, is a permanent part of the building's electrical infrastructure. Fifthly, industrial safety regulations also play a role. These regulations, including those related to electrical safety, lockout/tagout procedures, and PPE, often dictate the safe use of electrical equipment in industrial settings. The presence of features like GFCIs and regular inspection requirements can further support the classification as industrial equipment. To ensure proper classification and compliance, consulting with a qualified electrical inspector or engineer is essential. This expert assessment considers all relevant factors, ensuring the equipment bench is installed and used safely and in accordance with applicable codes and standards. By understanding these factors and seeking professional guidance, the appropriate classification can be determined, promoting electrical safety and compliance in various environments.